Before you click that Create button in the Azure portal, you need to have a plan. Creating an Azure VM is more than just spinning up a server. It's a coordinated setup of networking, storage, identity, and performance that ensures your virtual infrastructure behaves the way you expect. Let's walk through the essential checklist for creating an Azure virtual machine. When you create a virtual machine in Azure, you're not just setting up a single server. You're actually deploying a collection of interconnected resources that work together to support your workload. You start with the virtual machine itself. This is the core compute resource where your operating system and applications will run. Think of it as your cloud-based computer. Next, you'll need OS and data disks. The OS disk holds your operating system, while data disk store application files, logs, or databases. Keeping your OS and data on separate disk is a smart move for easier backups and disaster recovery. Then comes the virtual network. This gives your VM a private, secure network to communicate with other Azure resources. It's similar to how your physical servers communicate on premises, just virtualized. To connect the VM to your network, Azure automatically adds a network interface. This acts like a virtual network card, enabling communication with other devices in your VNet or the internet if configured. For traffic control, a network security group is essential. It lets you define inbound and outbound rules, similar to a firewall, so you can control what traffic reaches your VM and what's allowed out. Finally, your VM will have IP addresses, either public, private, or both. These allow your VM to communicate with other services internally or externally, depending on your requirements. Azure can automatically create these resources for you, or you can choose existing ones. Either way, use clear and consistent naming to keep your environment manageable and easy to troubleshoot later. Before you even think about creating the VM, start with planning the network. Ask yourself, who will this VM communicate with? And what ports need to be open for that communication? These questions help you avoid connectivity or security issues down the line. Begin by designing your virtual network. You'll need to define your address space using private IP ranges like 10.0.0.0/8 and create subnets to logically separate workloads. For example, one subnet for front-end servers, another for back-end services, and a separate one for databases. Planning this upfront ensures cleaner traffic management and easier scaling. Next, focus on securing your network. Use network security groups to control the flow of traffic at both the subnet and NIC levels. By defining inbound and outbound rules, you can lock down your environment to allow only what's necessary, keeping your VMs protected and your apps running smoothly. Once your network is in place, it's time to name your VM. This name serves two roles. It's both the operating system's computer name and the Azure resource name. Keep in mind the character limits, 15 characters for Windows and 64 for Linux. You should follow a consistent naming convention to make resource management easier. A good format is something like prod AUI web 01, where prod indicates the environment, AUE is the region code. Web defines the role of the VM, 01 is the instance number. Using clear, consistent names will help you quickly identify and manage resources as your environment grows. Now, decide where your VM will live. Azure has data centers across the globe, grouped into regions like Australia East, West US or Southeast Asia. Choose a region that is closest to your users to reduce latency and improve performance. Also consider compliance requirements. Some workloads must remain within specific geographical boundaries. Each region supports a different set of hardware SKUs, and prices can vary. So check what's available and compare costs. If your workload isn't region bound, choosing a lower cost region could offer significant savings. When selecting the right size for your Azure virtual machine, you need to align it with the type of workload you are planning to run. Azure offers different VM families, each tailored to specific use cases. If you are working on development, testing, or hosting a low to moderate traffic website, you'll want to go with the general purpose VM. This option gives you a balanced ratio of CPU and memory, ideal for most common workloads that don't demand extreme resources. For workloads that are more CPU intensive, like application servers or batch processing, choose a compute optimized VM. This type gives you a higher CPU to memory ratio, making it perfect for tasks that require fast processing power. If your applications are memory hungry, like large databases or data analytics platforms, then a memory optimized VM is the right fit. These VMs are designed with a high memory ratio to handle memory heavy operations efficiently. To support data heavy workloads like SQL Server or other large databases, you will benefit from a storage optimized VM. These machines offer high disk I/O throughput, which is critical for performance in storage intensive environments. For scenarios that demand specialized graphics or parallel computing, such as machine learning, 3D rendering, or AI model training, go with a GPU VM. These are built with powerful GPUs to accelerate complex workloads. Lastly, if you are running scientific simulations or high performance financial modeling, you should consider high performance compute VMs. These are the fastest computer options available in Azure and are tailored for workloads that require massive processing power with low latency. When you create a virtual machine in Azure, you need to think ahead about how your storage will be structured. Every VM automatically includes a few essential storage components. First, you'll have an OS disk. This is where your virtual machine's operating system is installed. It's persistent and forms the foundation of the VM. Alongside that, there's a temporary disk, which is non-persistent and used for temporary storage operations, such as paging and caching. Keep in mind, any data stored here will be lost if the VM is stopped or deallocated, so never store anything critical on it. You also have the option to add data disk. These are perfect for storing application data, logs, and databases. It's a best practice to separate your application data from the OS disk to improve performance and resilience. Next, you need to choose the right disk type based on your workload and budget. If you are running heavy databases and need the best possible performance, go for Ultra SSD, which offers the highest UPS. For production workloads, Premium SSD is a reliable and high performing option. If you're working in development or testing environments, standard SSD will offer decent performance at a lower cost. For archiving or backups, standard HDD is a budget-friendly choice. Always match your disk selection to the performance demands and financial limits of your project. Separating your app and data disk not only improves manageability but also helps in restoring or scaling workloads more efficiently. When you set up your Azure virtual machine, one of the key decisions you will make is selecting the operating system. Azure makes this process simple by offering a wide variety of ready-to-use images in the Azure Marketplace. If your workload is best supported by Microsoft's ecosystem, you can choose Windows Server. It's a great option for Active Directory, .NET applications, or any services that rely on the Windows environment. Prefer Linux? Azure supports several popular Linux distributions, including Ubuntu, Red Hat, and SUSE. These are ideal for open source development, containers, or cost effective hosting solutions. You're not limited to marketplace images. If you already have a customized configuration you trust, you can upload and manage your own custom images using Azure Compute Gallery. This helps you maintain consistency across environments and speed up deployments. Lastly, if you want to skip the manual setup, Azure offers pre-configured full-stack solutions like WordPress or the LAMP stack. These are ready to deploy and save you time by bundling everything you need in a single VM image. Before you deploy your VM, it's important to understand how Azure pricing works so you can optimize your costs. When it comes to compute, you have two pricing models. If you need flexibility, choose the pay-as-you-go option. You are charged per second, which means you only pay for what you use. This is perfect for short-term workloads, testing, or development environments where usage is unpredictable. If your workload runs continuously or long-term, consider reserved instances. By committing to a 1 or 3 year term, you can save up to 72% compared to pay-as-you-go pricing. It's ideal when you need price predictability and you're confident about your VM usage over time. Storage charges are separate from compute. Even if you stop and deallocate your VM, you're still billed for the disk storage used by your OS and data disks. Plan accordingly so you don't get surprised by ongoing storage fees for idle resources. There are additional costs to keep in mind. If your VM uses a public IP address, that comes with a charge. Optional services like backup, monitoring, and diagnostics may also add to your bill, but they are valuable for reliability and visibility. Lastly, consider the cost of the operating system license. For Windows VMs, Azure includes licensing in the hourly price. If you have your own license, you can use the Azure Hybrid benefit to reduce costs even further. So, what's your key takeaway? Creating an Azure VM is simple when you follow a checklist. It helps you avoid surprises, control cost, and ensure scalability and security. Use this checklist every time you build VMs, especially during migrations or setting up production workloads.